Hi, and welcome to Geeks for Geeks. I'm Siddhartha Hazra, and today I would be the one who would be discussing the Geeks for Geeks Weekly Coding Contest. So, who am I? I'm a software engineer at Geeks for Geeks. Besides that, I'm also a competitive programmer too. Back in those days, I did ACM, ICPC, and all the Code Forces guy. Okay, fair enough. Let's talk about the feedback of this problem. What, according to me, was the general idea, and if I was the sole creator or the sole person, what would be my feedback as a simple participant too? Okay, fair enough. Let me just share my screen itself. Give me a quick one in the chat if I'm perfectly audible as well as equally visible, and my screen should be now added. Yep, fair enough. So these were the four problems according to this point. So the four problems were this. So counting a n digit number with a 7, okay, and odd minus prime get segments. So according to me, this should have been the very first problem, okay, and this should have been the second problem, and this should have been the third problem, and this is of course in the perfect position, which is 4. Now the thing is, if I just talk about briefly about all the problem, this problem is a good problem which uses the concept of permutation. Okay, good enough problem. But the point is that this contest is being conducted on a platform like Geeks for Geeks. So we don't expect a lot of competitive programmers, and seeing a math heavy question in a DSA platform is somewhat not frequent. So I would suggest that if this is a problem in code forces and these were the question, then this is at the perfect position. But this is the position of code forces at Coder and all. They are comparatively math centric. That seems good. But here you should have been on the third place. Okay. Odd minus perhaps a very trivial problem comparatively. We don't really need to think a lot. Okay. Like I would say just play with primes. Okay. Just you need to play with primes. And even if you're not good with primes or something, you can simply do a good Google search. Okay. To know how it's being done, and you can learn it and implement it at that point itself. I would say this is a problem where you can do a Google, like you can solve it using Google search, to be honest. Get segment was a problem where you need to think straight and simple. Okay, just think straight and simple. So if you were a person who solved this problem using binary search, that is an overkill for this problem. Just you need to think straight and move forward. Now the last problem is comparatively a very introductory problem of something known as digit DP. Okay, a very good problem indeed, but a fundamental problem. If you if you have already solved up problems from at coder DP contest, okay, then this problem is very akin to that problem. Like I would say, a very inspired version of that problem. These were my views and what all topics it had a hit. Overall, this was a good contest where I think that they should have added more creativity to this get segments. Okay, so fair enough. Let's move forward. Other than that, everything is good enough. Okay, now third should be one. Yup, that is why I told. Yep, you can think that is a very simple problem. It was a hard contest. Yes, if you consider the last problem, it was hard. So can we solve odd minus sliding window? Not even sliding windows required. A simple, like any algorithm to that apart from prime sieve is an overkill to this problem, I would say. Okay, so let's start discussing the problems. We would discuss them in order in which they were given. Okay, this is comparatively a very nice problem if you ask me. So is the contest still running? What is the time frame of this contest? Damn. No, no, no. बच गया. Okay, fair enough. Let's move then. I thought the contest is still running. It was showing me a timer at that point. Okay, fair enough. Mhm. Like this is also comparatively easy problem. Like you should, like yes, it is indeed that you should already know these type of problems, but it is comparatively a easy problem if once you do it. Okay. So now let us see this problem. Given a positive integer, you need to count the number of values which contain at least one 7 in it. At least one 7 in it. Okay. So count of two-digit number. Count of two-digit number. So it would start from, I would say it would start from 11 and it would go till the value of 99. Here it would have like, it can't contain non-zero. Okay, that is not mentioned here, but you need to. So the numbers, the count of numbers should have no leading zeros. I think this was needed, but given the sample test case, you can bear it that without this also you can solve it. Okay, so now see, if I talk about all the two-digit numbers without any leading zeros, it would start from 11 and it would end at 99. If you ask me, so what are the values which have at least one 7 in it? The values would be 17. Okay, so let's just solve it here itself. Okay, if asked n is equals to 2, so we need to take care of all the two-digit numbers that have at least one 7 in it. So all the two-digit number which does not have any leading zeros would start from 11 and would end at 99. Both are inclusive. So the values that have at least one 7 in it is 17, 27, then it is 37, then it is 47, then it is 57, 67, and then it is 71. Because see, this has at least one 7 in it. Then it has at least 17, 173, 74, 75, 76, 77. Then it would be 78 and 79. Then if you see again, it would be the general trend that it would be again 87 and then it would be 97. Okay, if you see, all these are good enough, but if you just see up this general trend, everything is just 17, 17, 27, 37, 47, 57, 67, 87, 97. But only from 70 to 79, because of the presence of one that number, we got this. So what is the count of this value? The count of this value is 1, 2, 3, 4, 5, 6. 6 plus 9 is equal to 15, 16, 17. I missed anything. Did I miss? I think I have missed up. 27, 27, 37, 47, 57, 67. Okay, I missed 70. Okay, fair enough. My mistake again. Okay, fair enough. Okay. So that is why the answer to this, the count of the element is 18 itself. So now see, which have at least, let, let's try to think it in a different manner. Okay, let's try to think it in a different manner. See, it's just like the idea. The idea revolves around this, that let's say, just think in this fashion. Okay, please just think in this fashion. Like, let's say we start off. Yep. So let's say I am a gym freak. Let's say I eat a lot of eggs. One day my mother got frustrated, and then she told me, okay, then she told me, tell me any day, tell me the number of days in this current month, number of days in the current month where you ate at least one egg, where I ate at least one egg, at least one egg. So let's say generally I eat a max of how many eggs? 6 eggs in one day. Okay. So let's say what I did was I started to find out how many days I ate one egg, how many days I ate two egg, how many days I ate three egg, and how many days I ate four eggs. Similarly, till 6 eggs, and the summation of this would be the answer of what my mother is asking. If the number of maximum eggs I was eating is more than 6, let's say the number of eggs at max I can eat is 10, then I need to do this till one egg, number of days I ate one egg, two egg, three egg, four egg, until the 10 egg. If the number of max egg increases, then we need to increase this value a lot. We need to increase this value a lot. Instead of that, a better solution to this in real life analogy would be that total number of days minus the number of days I didn't eat any egg. And this would also drive me to the same solution. Total number of days minus the number of days I didn't eat any egg would be the number of days where I ate at least one egg. And this thing is independent of the number of eggs I eat max. Now, even if the max is 100, this equation would still be same, and it would just require a simple one subtraction. Fair enough? Here also, in this question, what is asked? Number of values which contain at least 17. So what I can simply do is total number of n digits, and it is and subtract numbers with no digit as 7. Fair enough? So now even if the n is large enough, we just need to do one subtraction. One simple subtraction would solve the issue. Total number of n digit is comparatively easy to find. How? Let's say n is equals to how much? N is equals to 2. Then the range would be from 1 to 99. N is equals to 3. Then the range would be 1 1 0 0. Sorry, this would be 10. Okay. 100, from 100 to 999. This would be all the numbers which are 3-digit numbers. And number of digit which does not have 7 in it, that is the problem statement now. So now we need to find the number of digits as 7 and total number of n digits. So even if the n is large enough, we don't need to really do any pre-computation based on n. Okay, hope you got my point. Am I clear with this idea Then finding out the count of it is a different era in itself. But first tell me if I'm clear with this hack or not. Hi Nekaj, how are you? Okay. So first tell me if I'm clear with this idea or not. Just give me a quick 1 or 0 in the chat. Just a quick 1 or 0. Am I clear with this idea? Okay. Just tell me the point, Hemant, at which you're not able to understand. So I would, at this point, I would try to move forward. So now see, total number of n digits. We can clearly see that this problem is a kind of permutation combination based problem. So now we have two options in front of us. We have two options. We have two options in front of us. This is absolutely important, but because for a person who is not very good with JEE means JEE advanced, like not good with mathematics, I would have a consolation for him because I'm not a JEE person back in those days. So I would help him. So basically, if you observe, this is a permutation combination problem. So to compute any of the combinations like this, we have two ideas. That is the very first is to यहाँ पे permutation लगेगा या combination. यहाँ पे permutation लगेगा कि combination. So just making your base better. We use permutation when the order matters, and we use combination when the order does not matter. Does not matter. So now let us see if the order matters here or not. So now if you see, yes, indeed the order matters here. How? Because 17 and 71 is treated differently here. 17 and 71 is contributing, both are contributing one to the answer individually. या इसलिए यहाँ पे permutation लगेगा, not combination. इसीलिए you don't, इसीलिए at this point only, after seeing this, you shouldn't think of NCR or NC2. Don't think in that direction. Order matter कर गया मतलब permutation. I have seen this in a lot of people, including me back on those days, कि I was not really able to figure out कि कब permutation कब combination लगेगा, and I started thinking combination जो नहीं लग पाया I would have used that. But there is a proper idea behind this. Okay, in case you don't know. So fair enough, let's move forward. So यहाँ पे permutation लगेगा. ला कैसे लगेगा? Let's say the number of values is equals to 3. Let's say the number of values is equals to 3. Let us first find this total number of n digits that I can create. So I can't have leading zeros in it. I can't have leading zeros in it. So number of digits I have is what all? I have from 0, 1, 2, dash, dash, dash till the value of 9. So in total I have how many digits? I have in total 10 digits. Fair enough? So total number of digits now. Okay, total number of digits now. So if I can't have any leading zeros, then the number of digits, number of values I can use here is from 1 to 9. Because यहाँ पे 0 नहीं रख सकते, 0 रखूंगा तो it would have leading zeros. In here I can have 0 to 9 everything because it is not the leading position. Here it is also 0 to 9. If it had been more, that would also be 0 to 9. This is also 0 to 9. So now if you ask me, the total number of n digits that we can have is how much? It is 9 multiplied by, this is what? All the position except leading position. So it would be 9, sorry, it would be 10 values because 0 to 9 means 10 values. It would be 10 multiplied by n minus 1 number of times. This is what? Total number of n digits that we can have. Okay, this is how. And by just doing this, you can even find out the number of digits with number of n digits which does not have 7 in it. See how it is easy to calculate. Okay. Now my next problem statement that we have is to find out number of values, and it should be n digit with no 7. See how it is easy to find out with no 7 in it. So see, let's say we have 4-digit number. We are told to find out the number of values 4-digit. So here I can't have leading zeros. We talked about it. So I can't have here 0. I can't have here 0. I also can't have here 7 because no 7 means that I can't have 7 at any position out there. So I am not taking two values. So that means I can use here 1, 2, 3, 4, 5, 6. I can't use here 7, 8, 9. Okay. And here I can have how many values? I can have all the values from 0 to 9, but not 7. I can have all the values from 0 to 9, but not 7. I can have all the values from 0 to 9, but not 7. So this just means that I can use how many number of digits here? I had 10 digits and I'm not using 2 digits. So I'm using 8 digits. I can keep here 8 digits at this point. And here I can keep here 10 minus 1, that is 9, 9, 9. So the number of values which does not have any 7 is 8 multiplied by 9 raised to the power n minus 1. All the position except the first position. That is why 8 multiplied by 9 minus. So basically the solution to this problem is nothing but simply 9 multiplied by 10 raised to the power n minus 1 minus 8 multiplied by 9 raised to the power n minus 1. Fair enough? So this is basically the solution. Now, am I clear with this idea or not? Give me a quick one. Till then, I am telling you one more general idea of this question. The one more general idea is that as we need to compute a large value of x and y, so to do that, we are using here binary exponentiation. Binary exponentiation. So basically, if the n was small, then we could have simply used up this formula. But as the value of n here is large, so we are using binary exponentiation here. Okay, so I won't really explain the whole point of binary exponentiation. I would urge that you go out and simply learn binary exponentiation to just solve that sub problem in it. So now just showing you the code at this point, and it is comparatively, I don't really need to copy paste this. This is the binary exponential to compute a raised to the power b modulo 10 to the power something. Okay, we are not seeing this because this is out of the scope of ours. You can just learn binary exponentiation and come back. So now that is why here it is written 9 multiplied by 10 raised to the power n minus 1, and without 7 is how much? 8 multiplied by 9 raised to the power n minus 1. Now we just subtract total minus without 7, and that would also give you more. Now one more thing which I wanted to tell you is, as here the value of n is large, so here it won't work. But if the value of n is small, like we discussed that idea of egg. Na? If the max number of egg I eat is 3, then we can simply use number of days I ate 1 egg, number of days I ate 2 egg. So here also we can use that the number of values with 1, 7, 2, 7, 3, 7, 4, 7. But as the value of n is very large, so computing it would give you a time limit exceeded. So this idea is needed. So that's a wrap from my side. If you still have any confusion regarding this, make sure you ask me. Else, I would simply move forward over here. Hi Prashant Shukla, how are you? This is not expected from a person who would be sitting for an software development role. Very well explained. Chalo, okay. Explain the modulo operator So you can just see modular arithmetic if you want. Here we are just to solve it. So you can just see here modular arithmetic. Then you can simply see what is a plus b whole modulo, what is a minus b whole modulo, what is a multiplied by b. Then the only point of a little bit of diversion is a divided by b, where we use something known as modular inversion. So I think that's a different set of class that you should have, and that's a different set of learning that you should have. So I would urge that if you don't know this modular part, kindly learn that in a separate manner. Okay, fair enough. Long mod, why we used it? Okay, let me just see. Okay, so long mod, I'm using it because the modular because this every value is in, so this value is in int, so I know that the values would be bigger. So to handle big enough values in online compilers, what we basically do is, here the space doesn't really contribute so much to the complexity, the space complexity. So what we do here is, I'm using long. But by the way, you can simply use int here. That's my style of writing the code. You can simply use int here because int is only given. You can simply use int. That won't be an issue. That's my way of writing code. Okay, but 8 part not, sir, 9, why minus 8? Okay, this one. So I told you ना, I explained you. See, देखो बच्चा, ध्यान से देखना, आप ही के लिए समझा रहा हूँ. ओके, चलो देखो, ध्यान से देखो. We discussed that we can't keep leading zeros over here. So here we can't keep here zeros. And then we also discussed here that we can't have here 7 also. So we in total we have how many digits? We have 10 digits. But we can't use here 2 digits. So here 8 and here we can use 0, we can use 0, we can use 0. That is why we can say that 8 multiplied by 9 multiplied by 9 multiplied by 9 itself. Basically, that is why we are discussing 8 at this point. If you're still not able to understand, consider watching it again. Just go back and watch it again. Let's move forward to the next problem. Comparatively, this is, I won't really, like, you don't really need me if I just tell you a simple idea of this. Not even the sample test cases are required, I would say. Okay, so see, the idea is comparatively simple. Okay, बहुत simple problem. इसीलिए I told you that this should have been the second problem. Okay, now see, the idea is comparatively on the very simpler side. Given a positive integer n, okay, we have a positive integer n. The problem is to find the maximum sum of exactly k integers from the set which are odd but not prime. Okay, so which are odd and not prime. These are the only two things I require. Okay, so now see this. Okay, let's say the value of n is equals to 20. Let's say the value of n is equals to 20. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That is why they didn't give a good sample test case that when the value of n is good enough. If the solution was given where the value of n was good enough, like big enough, then you could have the solution. Now let me show you how the solution is coming up. Chalo, let's see this. देखो, What are the values which are odd but not prime? Odd but not prime. This is okay. 3 is odd and it is prime also. 5 is odd as well as prime. 7 is odd as well as prime. 9 is a value which is odd but not prime. So we have a potential candidate here. 11 is a prime number which is odd also. 13 is also a prime number. And then we go to 15. It is odd, but it is not a prime number because it can be divided by 3. Then we go to 17. 17 can't be divided by anyone. Now, the next value we have here is 19. 19 is also a prime number. So let's say if the value of n, let's increase it more, then you would have better idea. 27, 28, 29, 30, 31, 32, and 33. Now see, then we have 17, then we have 19, then we have 21. It is also a prime odd number which is not prime. Then we have 23, it is an odd number and it is a prime number. It can be divided by 5. And then we have 27, which is a odd number which is not prime. We have 29, let's just forward it. And then we have 33, which is odd but not prime. Now if that given a number 34, given a number 34, find the find three values which are of this category, and it should be what? It should give maximum sum. Again, translating the same in Hindi, for that you have a better connection of course. 34 तक वैल्यूज बताओ जो ऑड है और प्राइम नहीं है, और उन सबका सम मैक्सिमम होना चाहिए. ऐसे 3 नंबर बताओ. So what would be that 3 number which would contribute maximum sum? So the general idea would be that I won't select the values which are small. Obviously, I would select the values which are large enough, and it would be towards the boundary. अगर मुझे बता दिया गया है कि I can use my full potential inside this limit to have maximum sum, I would obviously select the big values that I can have. So it's simple. We would simply take these 3 values. So this is basically the idea, that we would first find the potential candidates, then we would start iterating from the back, and then we would just take the last k potential candidates and give it out as an answer. This is the solution. Now, as we are talking about prime and the number of prime numbers that we need to operate upon is big enough, that is why we are using something here known as prime sieve. That is why we are using here something known as prime sieve or sieve of erytherosis, that we generally say, because हमें बहुत बड़ा रेंज में प्राइम की सारी इंफॉर्मेशन रखनी है. Okay, so we are given a range and we need to, and the range is good enough and we need to operate on primes. Think about prime sieve. So just that, simple enough. So am I clear with this idea? Just give me a quick one, or do I need more explanation? But I am not getting a good reason to explain more. Okay, as prime sieve is a general algorithm and out of the scope of this syllabus, solving this problem is the main goal of this stream. So I would simply skip the explanation of prime sieve. I think you should separately learn it, prime sieve, then segmented sieve, and use prime sieve to find smallest prime factor and do prime factorization. These all series of events should be your homework. Okay, by the way, all all the things that I'm talking about. Like if you talked about modular thing, I told you a lot of things, modular inverse and those things. If I you asked about prime sieve, I told a lot of things. So just tell me over. So now I propose a simple idea of this. So as this weekly coding has a good amount, so just give me a quick one. Okay, so now very like it's special with my stream. So and it is feasible from my end. So what I propose is that in this stream we have a lot of prerequisites like modular arithmetic. Then we have talk about prime sieve, sieve of parenthesis. Okay, so if I get 100 comments to explain a certain topic, then I would arrange a separate stream and I would teach that whole topic. Now you are the sole decider which topic you want me to explain, or if that is needed or not, or you can learn it from a separate resource. That is also fine. Let's go to the third last one. Now let's head back this. So am I clear with that idea? Got it? Okay, chalo. Use Sarinda. Why don't we go from the last and then find from last? First, we would find everything and then we would start from the last. Like there is no algorithm. Like so. Okay, I didn't show you the code, na. Sorry about that. Mhm. Mhm. It should give me a right answer. Okay, for the value is till 10, your code output is 18. Okay, let's just take up any solutions from the backend. Mhm. Is this a good solution? It is not a prime. Yes, fair enough. By the way, I found the issue. Mhm. Not a basic zero and then minus minus. Yep, fair enough. So now let us discuss, and what I did that also I will discuss. Don't worry about those. So get all prime numbers up to, this is the part that I want to explain. So basically, so now see, am I streaming my, okay. So first we would find all primes. Find all primes. Then if it is an even number, then we subtract 1 from it. Then if it is an even number, we subtract 1 from it. Then after that, we would start this. Like if the given value is 9, then 7, we would check for 7, then 5, then 3. That is why if the value was 10, I just subtracted it so that we can just hit upon 573. So we are iterating on all the odd numbers only. Basically, you can iterate over everyone. And then if that is not a prime number, so we are already iterating on odd and it is not a prime number, then we would add it to the sum and decrement the number of values that is needed. At the end, if we have collected all the values, then we would simply return. If we were not able to collect all the k values, like if k values were not present, if let's say k is equals to 4 and n is equals to 10, then we won't be able to fulfill that wish of them. So in that scenario, we are returning a -1 to the result itself. Okay, hope I am clear. That's the solution much itself. Okay, you want the code? Take this. Mhm. This is the code. Can't we find prime and add it to a vector and add all the big K terms? This is what we are doing. Now the last one is get segment. Comparatively, kudos to the people who tried to do this using binary search. Okay, seems like a binary search problem when you say that minimum or maximum back in that idea. But here we don't really need the idea of binary search, to be honest. Even I saw many submissions of that using binary search, but that is not that much required. Why? Because you are given an array of integers and an integer x. The task is to divide the array into contiguous segment. So we need to divide the array into contiguous segment. That means contiguous segment means what? Like let's say this is a1, a2, a3, a4, a5, a6. Then we need to respect this segmentation and we need to keep up with the order. Okay, but one thing to note here is that it is told to divide the array into contiguous segment of equal length is not given. So it can be that the first segment is of size 4 and the next segment is of just of size 2. So when the division of the array into unequal segments is being done, so as we have the requirement as unequal segments, so for all the people who tried to go on towards binary search, so if we have something known as unequal segments, you shouldn't go towards the idea of binary search, because binary search वहाँ पे ज़्यादा अच्छा perform करता है जहाँ पे the fixed idea is given. Like we are dividing all the arrays into fixed size. In that scenario, binary search seems to be a very good fit in that. But for this is a kind of a little bit of overkill. Okay, so now each segment or of each segment is less than or equal to x. So what is this? What is the question that is asked? Like you can divide the segment in any way you want, just it needs to be consecutive. And the question that is given, or of each segment should be less than equal to x. And let's say if we have a value known as a1, a2, a3, a4, a5, a6, a7, a8, and a9. Let's say we have this one. So let's say it is a very clear idea itself. Like let's say we started doing the OR from here, and then we got here. Until this point, the OR was less than equal to x. But if we include this element, then it is greater than it is becoming greater than x. So we don't include this. Then we would again move from this to this to this to this. Until this point also it was greater than equal to x, but when we hit this point, where if we are including a of a8 into the second segment, then the value is becoming more than x. So we are not including it. Then the rest of the values, let's say it is less than x. And this is indeed the idea of what we are doing. We start doing the OR from the first position. Whenever we observe that we are getting out of hand, we just start a new segment. Again, we start doing the OR. When we observe that the value of OR is getting more than what we desire, like more than X basically, then we start a new segment. And that is indeed the idea. No discussion of sample test cases or something is required. Just a simple brute force is enough to solve up this problem. No sliding window. Why don't even sliding window? Because sliding window also works on the problems which has fixed window size. If you observe, the window is sliding, so everywhere the window size is fixed. So if you have a requirement that you only need to divide the array into contiguous segment, no clause about the size of the segment, then simply move towards something else. Why to bulk up your head with something like sliding window? Binary search is not required. यहीं से you have the intuition कि I should go in which direction. पहला प्रॉब्लम में क्या था? अच्छा, ऑर्डरिंग मैटर करता है, सो आई शुड गो इन द डायरेक्शन ऑफ परम्यूटेशन. ओके, सेकंड प्रॉब्लम में क्या था? हमें क्या करना? मैक्सिमम वैल्यूज निकालना है, तो मैं नीचे से वैल्यूज निकाल लूंगा. सिंपल इनफ. Okay, you don't, like someone would tell me, find all the values, sort it, and then take the last four values. No, not at all. Just start observing it from the back, and you would indeed have big values. Here you don't have equal segments, so कहाँ पे जाना है? Two pointers की तरफ जाना है if the brute force is not working, because two pointers deals with the algorithm which has unequal segments. Fair enough. This was it. The solution would be simply this thing only, what I am telling. Okay, so we start the ZOR value or value as 0. Then we say that this is the current index we are starting off. Okay, now till the point it is less than n, like till the it is a clause that less than n, and then till the point we are able to have the value less than x, we would keep going. If at any point we have the value greater than x, we would break from that condition, and then we would increase the number of segments, and then we would say please start again. Simple enough. This is the solution, a 4-liner solution. I think this should have been the first problem. Fair enough. So am I clear with this idea? Give me a quick 1 in the chat if I'm clear with this idea or not. Am I clear with this idea? Just give me a quick 1 in the chat. And let's go to the last most interesting problem where the fuss is all around. I hear a lot of fuss that house, like I see a lot of comments like the fourth problem, the mentor didn't explain and all and all. But to be honest, I love this kind of complex problems. मुझे मजा भी नहीं आता simple problems समझाने में. I'm saving my time so that I can invest my time over there. So simply start off. Just keep the flow going. I want to explain the fourth problem badly. Done. I am not seeing any problems issue up till this point. So let's go to the last problem. The last problem is absolutely an elegant in itself. Okay, fair enough. Let me first explain you the problem as a ritual, and then we would talk about what can be the solution to this problem. The prerequisite. Now, before I start off with the, okay, first let me explain you the problem, and then I would tell you that. Given two positive integers L and R, count the numbers in the range sum of digits 1 to 10. 1 to 10 is 0, 1 to 10 is 1, 2 to 10 is 2, 3 to 10 is 3, 4 to 10 is 4, 5 to 10 is 5, 6 to 10 is 6, 7 to 10 is 7, 8 to 10 is 8, 9 to 10 is 9, 10 to 10 is 10, 11 to 10 is 11, 12 to 10 is 12, 13 to 10 is 13, 14 to 10 is 14, 15 to 10 is 15, 16 to 10 is 16, 17 to 10 is 17, 18 to 10 is 18, 19 to 10 is 19, 20 to 10 is 20, 21 to 10 is 21, 22 to 10 is 22, 23 to 10 is 23, 24 to 10 is 24, 25 to 10 is 25, 26 to 10 is 26, 27 to 10 is 27, 28 to 10 is 28, 29 to 10 is 29, 30 to 10 is 30, 31 to 10 is 31, 32 to 10 is 32 This is indeed to be written. Sum of digits is divisible by number of digits. And we need to find what? You need to find the count of it. How many values are like that are lying in the range L2R. Okay, just like from 15 to 30. If you observe, we have first have 15. So let us see if the sum of the digits, that is 6, is divisible by number of digits. Yes. Then we have 17. Sum of the digits. Sum of the digits is 8, and the number of digits is 2. Then 19. Sum of the digits is 10, and the number of digits is 2. Then we have 20. So sum of the digits is 2, and the number of digits is also 2. Then we have 22. Sum of the digit is 4, and we are dividing it by 2. So yes, this is the count, and that is why we are having this. Okay. So now seems like a simple problem. Okay, indeed, like simple problem, just go from L to R and find it. But when you would go to the constraint itself, that is what makes up all the difference. So if you observe the constraints here, you can see that the value of L to R, the value of the range, is absolutely huge. That is 10 to the power 18. And by no means I can have a ON solution to solve up this problem. So this is a very good indication that whenever you are told, like a very simple indication of this kind of problems, whenever you are told to play with digits, whenever you are told to play with digits, and the constraint is unusually high, and the constraint is unusually high, then that problem is none other than a problem of something known as digit DP. Okay. Now, before I talk more about how to solve up this problem using digit DP, I did a simple YouTube search of digit DP, like digit DP concepts, and I was not able to find a satisfactory video of educator where he is teaching digit DP in whole. And digit DP is coming in the recent trends now. Now, comparatively, earlier what used to happen, like for companies like Google, Coordination and all, Triology and all, they used to ask this kind of problem. But in the recent trend, when the competition is becoming good enough and people are good enough with DSA too, then digit DP is also asked by startups, mid-level companies. So if you are a person who is a standalone coder or a lone wolf who loves to only learn from free resources, and I am a person who did all his programming from free resources, so that's a favor to them. So if I get 100 individual comments from different people's of source, not once spamming the whole comment section. So if I get 100 unique comments, like 100 comments from unique folks demanding a video or a series over digit DP, my commitment is that I would do it. Okay. And considering the number of views this weekly videos has, it has primarily most of the times it is the count is more than 1,000. So I'm expecting at least 10% of the folks to comment and ask for digit DP, and I would have a session over that. Okay, because I was not able to find free resources over that, video resources over that. It's your take it or leave it. But I would love to have, because I found that the need of this. Okay. Now let us move forward. Now see, how will we solve this problem using digit DP? So see, this problem is solved by using the idea of digit DP is kind of visualized in the form of trees. So from each node, the first value I can keep is 1, 2, 3, and I can go till the value of 9. I can go till the value of 9. Similarly, the first digit, if let's say the first digit taken is 1, then the next digit I can take off is 2, then 3, then 4 again, then 5, then 6. So similarly, as we go down, we can keep taking digits as we are going down. Okay. So now let us try to find out the number of values for a simple test case like 15 to 30. Do we have any values? 15 to 30. So now see what we would do basically. So let's say L is equals to 1 and R is equals to 30. Simple enough. So now let's start from this point. The very first value that I wish to take is 0. So 0. But as this taking 0 would be less than L, so we can't go in that direction. So I would just mark it that I am not going. Then I would tell you what this basically means. Okay, so the first value I can take here is, so the first value I can take here is 1. Then I can also take here 2, then 3, then 4, then 5, and these all are originating from the root itself, 7, 8, and then 9. So we are taking all the values which are originating from this. Okay, fair enough. We took all the values that are originating from this point. Now, the very next one is that after 1, can we take 0? Yes, here we can take 0 after 1 because it is greater than L. So we can take here 0, then again we can take here 1 because 11, then 2, then 3, until then we can take here till 9. See this. And then same goes for 2. From 2 we can have here from 1 till the value of 9, that is 29 basically, 29, and still that value is less than 30. Good enough. But if you observe from here, after 3, if I keep any value, after 3, if I keep any value here, so I would draw it here itself. So from 2, I can keep here 1 till the value of 9. But for all the other values like 3, 4, 5, 6, if I keep any values after that, like if I keep 4, 1, if I keep here, if I keep here 4, 1, 5, 1, 6, 1, 7, 7, 4, 8, 9, if I keep any values after 3, 4, 5, 6, 7, 8, 9, that value apart from 3, 0, apart from 3, 0. So we can keep here one value, that is 3, 0. But if we keep here 3, 1, that is not possible. So 3, 1 is not a valid thing. So I would again cut off this. Okay. I would again cut off this. So after 1, 0, I can't keep again more values. Why? Because if I keep more values, then it would be 3-digit numbers. So now I would be simply segregating the tree, like keeping the tree in different scenarios, like making the tree again for simplicity. And then we would be talking about the above tree. That above messy tree is important for us. Don't worry. So we can observe that we can keep here 1, and after 1 we can keep here from all the values till 9. We can keep here all the values till 9. Then we have again the value 2, and here also we can keep do the same, like 1, then 2, then dot dot, then keep all the values till 9 itself. Then we have the value as the next value as 3, and after 3 we can only keep 0, and this is the only values that would be less than 30, from 1 to 30. Now this is how, if you solve up from 1 to 30, this is how the valid tree would look like. So there is a concept of, like, if you know digit DP, then you would be knowing this. Sir, Python solution, please. This is an era of chat GPT. Why don't you paste my solution and ask him to do a conversion instead of pleading of please in front of the whole number of people? You need to be problem solvers as a software engineer. Okay, fair enough. So now if you observe that this is telling me that you can't go outside of this boundary. If you go outside of this boundary, the value would be less than L. Same goes for here. If you observe, we were not able to go to any values in this side. So basically it is telling me that if you go outside this boundary, you would have values greater than R. So that is why we have a concept of tight. We have a concept of tight in digit DP. Tight from L or tight from R. So tight from L basically means that we need to respect the boundary. Tight from R means we need to respect the boundary on the right hand side. And free from it means that we can go from anywhere from this. Like from 1, I am free to choose any value, 0, 1, 2, 3, any values. Okay, so I can choose here any values that I can have. Simple enough. So now let's talk about, this is the concept of tight and all. Let's talk about the DP states of this. So now the solution that I am trying to build is, I would first find all the values, till the value of R, and I would also find all values till L, and then if I subtract from R all values, then if I subtract this thing, then if I do a subtraction of this, that would be my answer. Okay, basically you can do it in the one go also, that is you can directly compute the values from L to R, but in that scenario you need to take care of values, like you need to have tights from two sides. So this is the cunning implementation. Many competitive programmers who are experienced and they want to have a simplified version of the solution, they use this idea basically. But you can use this idea also, the tight from left and tight from right. Like you can, like simply what you can do is you can simply have two DP states at this point. Like this would tell me the level I am at, this would tell me tight from L and tight from R, and this would be the sum of the digits. Okay, so now if you're a person who is a who knows digit DP, then you would be knowing that the standard DP state that we use is basically for digit DP. We have, this is the level that we are talking about. For example, this is the level 1, this is the level 2. Level would just tell me how many digits I have been taking in this question. And then we have tight from L, tight from L, tight from R, and this would be, here it would be the sum. We can have here the sum of what is there. Now what does this L and R indicate? I indicate the level we are currently at. L indicate the tight, basically we need to respect or not. Like what I meant is, like, let's have a quick scenario of what this tight basically means. So let's say we have a solution like this, and the solution revolves around this. Let's say the solution are all the values that are inside this subtree. Okay. So now I would say that if I am at this position, then I am free from left and right. So the L value of L and R for this would be 0 and 0. That is, sorry, 1 and 1. That I am free from both sides. Okay. So particular DP state of this would be, if I discuss DP, and this level is 2 and free from both side, and the sum up till now would be whatever you want. And if you ask this person, then, like, let's talk about this node. Yep, this node. This should be a little bit like this. Yep. So if you talk about this node, the DP state of this node, the DP state of this node would be the level it is currently at. And then if you observe, you are free to go anywhere on this left hand side. So this value is 1, but on the right hand side it has to respect this boundary. So on the right hand side the boundary would be 0. Okay, this is the way DP states, and this is what tight basically means, that we can't go from here. Like what tight basically again means is, let's say we need to compute the value till 24, and let's say till 23. So less than 23 is allowed, but more than 23 is not allowed. So I would say for the value 23, for the node 23, after 23, the value on the right side is tight, that we need to respect. But here it is not tight. You can go here anywhere. Okay, this is what the idea basically means. So now compute all the values till R, then we would subtract the values till L, and we would find out the values. So let's talk about how would we solve up this problem. So solving it is comparatively easy. We would maintain a DP state like this. Again, the same idea for this problem also, where we would simply have a value of the level that we are currently at. Now, one more thing to notice here is that the sum of the digits, only contributes when it is non-zero. Like anyone would contribute to the sum of the digits, number of digits basically. Sorry. Yep, say. So now let's say that I tried to build out, like instead of writing 6, my program would write 006, and it would say divide by 3. And this is also valid, this is also valid. And so I don't want this. Like initially I can start from 0, then I can keep here 0 again, then I keep here 6. So sum of digits would come out to be 6. And if I divide it by the number of digits that is used, that would be 3, because I use 006. But this shouldn't contribute to the answer. 006 divided by 3, this is not a valid contribution to the answer. You got my point? This is a valid contribution to the answer. So basically, what we need to do is, we can understand from here is that skip leading 0. Skip the leading zeros in the count of the numbers. Like count of the numbers should also be correct, as well as like some of the digits won't be affected. Like sum of 006 is same as 06. So we need to skip the leading zeros. So we would only start, see, 6 0 is valid. 60 has 2 digits, but 06 should be counted as 1 digit. Okay, so how we can do that? So see, 6006, here the number of digits is 4, but 00606, here the number of digits is only 3. So we need to only start counting zeros. We need to only start counting zeros if we have seen a non-zero element. Simple. Simple problem solving idea to solve up this small subsegment. Start counting zero as a digit when we see a non-zero number. Okay, start counting zero as a digit when we see a non-zero number. Simple enough. We would only start counting or assuming zero, that yes, you have a position in my life when, like like I would tell you, like we see many films now where the girlfriends tell you that I would consider you as my love of my life when you are able to achieve something. Same goes here also. I would I would start the contribution of zero when I see a non-zero element, because the contribution of zero after non-zero element is good, but a contribution of zero before a non-zero element should not be included. Okay, so that is why we would introduce one additional parameter here. So we don't really need the value of left over here, left over here, because we are value still right, value still left. So we don't have the value of L and R that we need to take care. We only need to take care of this side. This side we are free to go till the value of zero. Okay, that is why I, and then we have the value, then we have the next constraint as tight also, and the very next constraint we have is non-zero, and the next constraint we have is sum of digits. So now let us discuss how would we do that. So as the level increases, okay, so if the value is tight enough, like let's say if we are told that only go till 8 Siddharth, don't go outside it, then we would simply start keeping zeros. We would start keeping values from 0 to 8 only. But if the value of tight is false, if that is not tight, then we would go to use our full potential, that is go till the value of 9. Okay, this just basically means that we would go till the value of tight. अगर कुछ टाइट में वैल्यू पड़ा हुआ है, अगर बताया गया कि इतना तक ही जाना, then we would only go till this point. If we are not given the constraint of tight, then we would go till everyone, that is from 0 to 9. So I would simply write this: if tight is present. If tight is not present, then we would use our full potential, that we would use all digits basically in this. And what is this basically? If you observe, this is just like contribution of, let's take a different color. This is just like using up the value 1, then 2, then 3. The sum of this would be 6. Then let's say this is 1, then let's say this is 3, and this is, let's say, 5. Then the 1, 3, 5, the sum of that would be 9. Okay, and the number of digits used would be given by this level, because let's say the level of this is 3. So if you observe, yes, indeed we have used 3 digits. So we don't need to keep a track of number of digits that we have explicitly. And this is enough to solve up this problem itself, where we have the level, we have a tight, and the sum of the digits. So fair enough. Now the same thing, we would just memorize it. Now let us see the solution. I don't want a message over here. After the video ends, comment it just inside the video, inside the bit like bottom of the video, recorded version of it. Now see comparatively a little bit nasty. ये हुआ ना कोड, देखो ये काफी प्यारा क्यूट सा कोड है. Okay, fair enough. Sorry for my cheesy lines. And let's first paste this. Statically. ओके चलो देखते हैं क्या है इतना. Digit DP, I would say once you understand digit DP and solve 5 problems around it, then you are done with this topic. Most of the problem out there of digit DP is comparatively very similar. Like थोड़े से constraint और problem solving का तड़का लग जाए and digit DP is done. Now see. Now see. What this basically does is, if we have computed all the n values, then we would simply check at this point that the sum we are getting from here, if that divided by the number of digits that we have used, if that is equal to 0, then we would return 1, else we would return 0. So only contribute it. The base condition is that we have used up all of n digits and then used all n digits, and now you just check if the sum is equal to digit sum. Simple enough. This is a memoization part, where if the answer is already calculated, return it, else you don't do it. Now let me explain you why this is. If you observe that if I don't have this, yep. So let's say basically how this works. Basically, I used to think a lot back in those days. Let's say this is the thing. So if you observe, the answer that would be contributed from this would be the answer the answer contributed from both of them would be same. That is why we would have here we are compute here. If you use recursion, then you would be calculating the same value again. Like I used to think a lot earlier. Like हम लोग यहाँ पे duplicacy, like where we use memory, where we use dynamic programming. We use dynamic programming when we see overlapping subproblem. Overlapping subproblem is a fancy word where we compute the same value again and again. Then we use dynamic programming. Other than that, we don't use that. Recursion is good enough. So back in those days when I was a beginner, I used to always think कि ये recursive code में memoization या dynamic programming आ क्यों रहा है? Where the heck I am computing the same value again? If you observe, two nodes which are free from both ends would bring up the same value for a particular level. That is why for a particular level, if that is free from both sides, we would be doing duplicate calls. To save on that duplicate calls, we are saving the result, and saving the result in recursion is known as dynamic programming. Otherwise, ये simple एक recursion ही रहता. Okay, so I used to think a lot why this memoization happens in digit DP. Okay, so now again told you the same scenario. If the tight thing is there, if अगर बोला गया है कि let's say you are told to calculate till 29 till 24 only, Let's say up till now you have 4 and you are told to calculate values till 24. तो मुझे पता है सिर्फ 4 तक ही जाना है, 4 से आगे नहीं जाना है. Tight means that आगे मत बढ़ना. I am giving you a boundary to respect. Okay, so if I am given a boundary to respect, I would respect that boundary, and this loop would go from and this loop would go from 0 till the value of tight if I'm given a boundary. If I'm not given a boundary, then I would use my full potential, and 1 के बाद जैसे हमने सब कुछ रखा, in the same manner I would use my full potential and try to keep all the values from 0 to 9. That is why if tight is not there, we are explicitly assigning 9 to that. Okay, now the only important part here is to just a single line which is absolutely very fun to understand, and it is absolutely a delight to understand it. As we go down, the level increases. So that is why this is I plus 1. Let us enlarge this. As we go down, the level increases. So that is why this is I plus 1. The number of the digit n would be same throughout. The value of the n given in the question would be same throughout the whole stream. No? Then we have a tight thing. Okay, let us see how that tight is being observed here. So agar if the tight that we got here is already 1 and we do dig is equals to ub. So let's say मुझे 3 तक जाने को कहा गया था. Let's say मुझे 3 तक जाने को कहा गया था. And currently the digit that I appended was, let's say we are told to find out till the value of 24 only. We are told to find out the value. Let's say, let me explain you here. Let's say we are told to go till find the value of till 24. So after 20, I tried to assign it 1. After 20, I tried to assign 1 to it. Then if you observe, the tight would be equal to 1 because I got a tight that yes, keep this as 4 only. Tight is equals to 1 because, but after assigning 1 to it, I can simply say that 2 1 एक बार अगर कम इधर साइड चले गए, मुझे राइट लेफ्ट साइड रेस्पेक्ट करनी है, मुझे लेफ्ट साइड रेस्पेक्ट करनी है. आई केम हियर. अब इस साइड तो मैं कहीं भी जा सकता हूं ना, क्योंकि मेरे में लेफ्ट तो यहाँ है ही नहीं, मैं 0 से k तक निकाल रहा हूं. सो अगर मुझे इस साइड रेस्पेक्ट करना है, अंडरस्टैंड. बट इफ आई गो ऑन दिस साइड, दैट इफ लेट्स से आई वुड ड्रॉ द ट्री आल्सो. लेट्स से this is let's say 0 1 2 and let's say 3 and let's say 4, and after that, so let's say we are told to respect this side of ours. So if I chose 3, then here I can go left and right anywhere I like. So that is why if the current digit I have appended is not equal to the value given, that is 4, अगर 4 नहीं है, उससे कुछ कम value है, then I can go freely. That is why and 0. So the value that would be passed on if I'm not using the full potential would be 0. That अभी tight था, आगे से tight नहीं है because मैंने lower value use कर लिया. But if I use the full potential of it, अगर मैं if you observe, अगर मैं इस 4 पे जाऊंगा, then we again have a tight to respect. यहाँ पर मैं freely नहीं घूम सकता, मेरे अंदर एक boundary है. So if I use the full potential, then this would be 1 and would also be 1, and we would be passing on that yes, please pass on that we need to respect the boundary. This is that. What is non-zero over here? Non-zero is nothing but simply doing a OR with that if the digit that we have observed up till now is greater than 0. Like if a non-digit, we discussed that now. If a non-zero digit is seen, then this non-zero would become 1 subsequently. Okay, then as we are appending each digit, we are adding that to the sum. Okay, we are adding that to the sum of the digit. And then what was this? Sum of the digits. As we are moving forward, we just keep appending the sum of the digits. Now the digit count would only increase. The digit count would only increase of 0 when we have seen a non-zero. That is why the non-zero is coming into picture over here for increasing the digit count. What is this digit basically? This is the digit count. So 0 would contribute as a digit. 0 would contribute as a digit in the computation when we have seen a non-zero. That is why we have a non-zero condition over here. You can evaluate this. This is a simple bit masking thing. And then SR would remain the same. So the only point of concern is this single line, which makes a lot of difference. And this easy implementation of digit DP is required. Why? Because if you see, even if you see the editorial of it, if I go and ask people to see the editorial, let's say you are a self-learner, and let's say you are a self-learner and came up and saw this editorial, this is very difficult to comprehend because this is a tabulation process. And in the initial days, you shouldn't learn tabulation, digit DP through tabulation. And then if you see the submissions also, then instead of this easy DP solution, what is this? This is base condition. ये memoization है. Digit DP सिर्फ यही for loop है. Other than that, everything is same. We are finding out the value till R, and we are finding out the value till L, and we are subtracting both of them. But if I just go around and see the implementation used by people, they're comparatively on a little bit on the nasty side. So I think a proper generalized education is required for people to understand that digit DP is not a rocket science. It is just another form of dynamic programming. Okay. So this is the solution. I would urge that you simply watch this explanation again after you know the basics of digit DP. Then you would get a complete hold of that. And I would urge that you inculcate this kind of implementation to your solution, because this kind of implementation would be the one which would lay your foundation for these all problems. So basically, this is the complete solution and the easiest form of solution for the last problem. And digit DP is indeed a prerequisite over here. And I'm not explaining digit DP over here because digit DP is a different one form of DP where we should discuss simpler problems of digit DP first, and then we should come on and discuss the at-coded problems, and then this should be the problem. This should be the third problem we should be solving. And in a stream where we are already discussing 4 problems, we don't have the bandwidth to learn a topic in itself. That is why I would urge that if you are a person who have a sync with my mindset that yes, we need a generalized form of easy education over digit DP, consider commenting on that. If the count is more than 100 from unique folks, then I would arrange a session either on Geeks for Geeks or on my personal channel. That's it from my side. If you have any concern or queries, feel free to drop your concern or queries in my LinkedIn itself. You can send me over a connection request over the LinkedIn too. Else you can just comment on the video till it is fresh, but after the video. So if you are a person who is watching this stream in the recorded version, or if you're a person who was with me till this point of time and you learned something out of it, considering that you knew the prerequisite, okay, and if you have a problem in my explanation and you knew the prerequisite but still not able to understand the solution of the problem, feel free to criticize me, and I would take the criticism in a positive manner and try to improve on myself. That's it for my side. This is me, Siddhartha Hazra, signing off. Meet you in some other day, in some other stream, taking up a new topic, battling with new problems. Till then, keep hustling and keep solving problems and getting your dream job. Thank you, everyone. Goodbye. Happy weekend.